Hey everybody, welcome back. 2.5 today. We're going to be talking about if-then statements and using deductive reasoning. I hope you're excited. Get ready. Okay, so we are going to be using if-then statements, but we are going to be applying laws of logic. And there's two laws of logic that we are going to learn about, and we're going to talk about those in just a second. First off, there are three definitions here that I would like you to write down: conditional statement, hypothesis, and conclusion. So please write that down, and then I would like you to write down the definition, so this, and the third column of the Venn diagram. So know both of those. Okay, a conditional statement, that is a statement that can be written in the form if P then Q. The hypothesis is that P part of the conditional statement. So if you're talking about the hypothesis, it is the front part, the part right behind the if, and a conclusion is the end part, so it's the caboose of the conditional statement. So it's at the end, it's after the then. All right, so let's look at some. After this, deductive reasoning. Please write deductive reasoning down as well. Deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to make a logical argument. So you are going to be using deductive reasoning to prove something correct by making an argument that something is true or not true. And we are going to be putting them in if-then statements. Okay, so the question is identifying the hypothesis and the conclusion. The question is, if I pass the driving test, then I will get my driver's license. Notice there's no yellow bar. You don't have to write this down. Don't worry about it. Okay, so if I pass the driving test, then I will get the driver's license. We talked about what is the hypothesis, what is the conclusion. According to our definitions, your hypothesis is the if part, your conclusion is the then part. So your hypothesis is at the very beginning. So here in red is going to be your hypothesis. That is in the conditional statement, that is the P part, okay, because remember, P then Q. If P, then Q. P is going to be your hypothesis, Q is your conclusion, and then you just kind of solve, okay? And the next part, what is our Q part of our equation? It comes after the then, and that's the underlining. Then I will get my driver's license. So, hypothesis, if I pass the driving test, then I will get my driver's license. Pretty easy, identifying the hypothesis and the conclusion. What I want us to do in these first two, we just talked about what that last example was an if-then statement. So now what I want you to do is write your own if-then statement. I'll walk this first one through it, and then I want you to do the second one. So it says rewrite the statement as an if-then statement. So something has to happen before your then statement. So the if, it needs to be before, the then is then after. Okay, so if I look at this, every game on my computer is fun, then I am going to do if a game, we know that if a game is on my computer, then the game will be fun. Okay, and we know that because in order for us to know that the game is fun, we have to know that it needs to be on the computer. It's not talking about other video games, it's talking about games on the computer. If it is a game on the computer, then the game will be fun. We will enjoy it. Try the second one by yourself. Alright, so I'm just going to go through the answer right here. Your hypothesis, the part where your if is, so the stuff in red is your hypothesis. The question is, I will buy the CD if it costs less than $15. That means if the CD costs less than $15, then I will buy it. Okay, you can't buy it until you know what the price is. So that price has to be first. If the CD costs less, then I will buy it. Or sorry, if the CD costs less than $15, then I will buy it. So that tells me there's an if this is possible, if that is true, then I will do this. If the first section is true, then you will do the second section. All right, excellent. Okay, so here are the two laws of logic. It's called the logic of detachment and the law of syllogism. Okay, so if you please write this down, I'll talk about them in just a second. All right, so the law of detachment, that is if P then Q is a true statement, P is true, then Q is true. So if P is true, then Q has to be true. That needs to happen. In order for Q to be true, P has to be true. Okay, the law of syllogism. That is going to be if P then Q and Q then R, then P then Q. What that means, there's a lot of P's, there's a lot of Q's, and there's even an R there. If, this is the law of syllogism. If A equals B, and we've kind of talked about this in the past, and B equals C, we can then substitute C in for B and make A is equal to C. That's part of the transitive property that you will learn about in 2.6. So if A then B, if B then C, then if A happens, then B happens. Okay, and we will talk about that in just a moment. So please write this down. I want you to rewrite this. So there's 3 steps to this. The very first one, rewriting it, then underline the hypothesis and circle the conclusion. Okay, so rewrite it as an if-then statement, underline the hypothesis, circle the conclusion. All right, so looking at this, it says all teachers at East High School have taught for at least 5 years. So you have to think to yourself, what has to happen first before I know the second part? Okay, and the if-then statement would be if a teacher works at East High School then I'm going to do he/she because it could be one or the other, has taught for at least 5 years. Okay, because if it was flipped around to be if a person has worked for at least 5 years, then they work at East High School, and that's not true because then they could have taught other places. We're focusing on East High School. If a teacher works at East High School, then we know every single one of those teachers has taught for at least 5 years. Now, you need to look at the hypothesis. So I'm going to underline the hypothesis. That's the if P then Q. The hypothesis is going to be your P. Your Q is going to be your conclusion. Okay, so the first one, underline the hypothesis. A teacher works at East High School. Then is going to be our back one, or sorry, our caboose. Caboose. He or she has taught for at least 5 years. So if you know that if then, or sorry, if you know the if, then you can put the then is. There's a lot of ifs, a lot of thens. Kind of get confusing. Just break it down into steps. If something is true, then something else will be true. Okay, next one. An angle is obtuse if it measures 170 degrees. If the measure of an angle is 170 degrees, then the angle is obtuse. we know that that has to be the true statement because we cannot flip this around. We cannot say if the angle is obtuse, then the measure of the angle is 170, because all obtuse angles are not 170 degrees. However, all 170 degree angles are going to be obtuse. Okay? So then we're going to underline our hypothesis, the first part, and circle our conclusion, which is the caboose. Gotta love the caboose. Choo choo. All right, let's move on. Now, so looking at this one, the question asks, what can you conclude from the given true statements? So here's the given statement. Okay, it says if x has a value, if x has a value of 7, then 2x minus 3 has a value of 11. And then they say the value of x is 7. So what can you conclude based on that first statement? And then they say the value of x is 7. Try this one now. Don't overthink it. What do you think? The value of x is 7. All right. Well, it says if the value of x is 7. Okay, it gives us the hypothesis, and then it says the hypothesis is true right in this second sentence. That means the hypothesis is true. That means your answer has to be 2x minus 3 has a value of 11. We know that if x is 7, then 2x minus 3 has to have a value of 11. It tells us that our hypothesis is true. So if it tells us that our hypothesis is true, then our conclusion has to be true. If it gives you a conditional statement, that very first sentence is a conditional statement, and then the second sentence is telling you that the hypothesis is true of that conditional statement, then the conclusion needs to be true. If P, then Q. All right, now tell me which argument is true. So please write this down. I understand there's going to be a lot of writing, or there has been a lot of writing today. We're almost done. Now, all you have to do is answer which argument is correct. So you can circle it and explain why, because it doesn't just say which one is correct. It also says explain. So please do that now. All right, looking at this, it says, argument 1 says if two angles are vertical angles, then they are congruent. 1 and 2 are congruent, so 1 and 2 are vertical angles, and there's supposed to be an angle symbol in each of these. Same thing with the second one. Okay, again, it says if two angles are vertical angles, then they are congruent. 1 and 2 are congruent, so angle 1 and angle 2 are vertical angles. Second argument, if two angles are vertical angles, then they are congruent. Angle 1 and angle 2 are vertical angles, so angle 1 and angle 2 are congruent. So what can we conclude? Which one is correct? Look at the hypothesis, then look at the conclusion. Okay, see if they state the hypothesis before the conclusion, and that is going to be argument 2. Argument 2 is correct because it says if this is true, if two angles are vertical angles, then they are congruent. Well, then it tells me, that second sentence on argument 2 tells me that the hypothesis is true. If the hypothesis is true, then the conclusion has to be true. Okay, if you look in that argument 1, it gives you, here's the conclusion. So 1 and 2 are vertical angles. Well, what if I just did this? Here's angle 1, and I said this is 53 degrees, and here's angle 2, and I said that's 53 degrees. Okay, there's two angles, but notice they are not vertical angles. So not all congruent angles are vertical angles. However, all vertical angles are congruent. Again, not all congruent angles are vertical angles, but all vertical angles are congruent angles. Okay, so the second one is true. And moving on. This is the last one of the day. You're writing the statement that follows from the pair of true statements. This is going to be the law of syllogism. So please use this. You're writing an if-then statement. Okay, an if-then statement using the law of syllogism. Give this one a shot. It says, if the daily high temperature is 32 degrees or less, then the water in the pipe is frozen. If the water in the pipe is frozen, then the pipe will break. Okay, so using that law of syllogism, that law of logic, okay, you are going to be finding an if-then statement. So we know that the law of syllogism means P then Q and Q then R, which means is equal to P then R. Well, this very first one, it tells us exactly what is happening. If the daily temperature is 32 degrees or less, then the water is frozen. Then you can see this statement right here, the water in the pipe is frozen. That's the conclusion of our first statement. However, it becomes our hypothesis in the second statement. Okay, so your answer will be, if the daily high temperature, and I'm just going to write temp for temperature, is 32 degrees Fahrenheit or less, okay, that's my hypothesis. So based on my hypothesis, I need to come up with a conclusion. But don't forget that second sentence. Then the pipe will break. Coming up with a logical argument, because we know we can substitute the pipe will break in for the water in the pipe is frozen, because both of those are equal. Okay, same thing. P is equal to Q. Q is equal to R. So we can substitute this R in for Q to make P equal to R. Okay, again, if you have any questions, you can rewind this, review it a little bit, or come to class tomorrow with questions. Write questions down. Make sure you don't forget. Okay, this is 2.5, and we are done.